Good morning, good afternoon, everybody. I'm Milene Aguiar, and I'll be helping out the webinar for today. Just a few heads up before we start. We have the next presentation in next month regarding the carbon emissions initiative, and we'll have a slide in the end of this presentation. After the presentation, we have time for questions. You can use the Q&A box in the bottom of the Zoom page. Please use the option send to everyone, not only for the presenter. I'd like to welcome Steve, who will present the webinar. I have to read his bio, just a minute. Let me introduce Stuart, to whom doesn't know him yet. As president and CEO of Cavanaugh and Associate, Steve is a creative visionary with an unshakable dedication to environmental. Steve, you should use easiest words for me.
Smaller words, yes.
Yeah, environmental stewardship and preservation, which has led him to work with public and private sectors, both nationally and internationally, for over 3 decades, developing innovative solutions to some of today's most challenging issues. Steve has dedicated his career to advancing water efficiency practices and harnessing renewable energy. His next frontier is illuminating the carbon associated with utility leakage and helping chart the course of effective reduction. He serves as a chair of the International Water Association Water Law Specialist Group Leakage Emissions Initiative. Steve has a BS in Civil Engineer from NC State University and is licensed professional engineer. And regarding to the webinar, considering everyone read before subscribing for this, we can say that the Paris Agreement demands global decarbonization, requiring innovative solutions across all sectors, including water. The AWWA Leakage Emissions Initiative, recently approved in North America, offers a powerful new approach. By focusing on leakage emissions as a key metric, we can unlock funding for vital water infrastructure improvements, simultaneously reducing non-revenue water and greenhouse gas emissions. So let's listen now how we can secure funding, reduce water losses, and contribute to global decarbonization. Is that okay, Steve? Can you share?
That's perfect. Let me make sure I'm sharing. Is that coming through okay?
Yes.
Excellent, excellent. Thank you. Thank you, Milene. And what's exciting is I'm looking at folks coming in, and I know that I'm presenting to a large part friends and folks that have been very active in the Leakage Emissions Initiative for the past couple of years. I've been excited about having the chance to present and have this webcast out there so that we can continue to expand and extend awareness and knowledge of what I think is an extremely powerful and something that is easy to grab hold of, how we can tie distribution system leakage to carbon emissions. And I've given a lot of this slide of this deck before. Many of you have seen it, but hopefully we'll have some time to go a little bit deeper, and then we'll have some time at the end to talk about it, because this group and the folks that are seeing it are the water professionals globally that can continue to extend this message out and to actually go deeper. I'm excited about the next carbon initiative, because this one, the Leakage Emissions Initiative, really is getting to its close, and it'll be a time where we'll be looking at stepping it forward and going deeper. So I've chosen a little bit of a twist to the title today. I hope you like it. It was catchy for me. The NR for NRW, new revenue for non-revenue water. And many times, certainly I have said, sometimes you have to have the vision and you have to put out there what it is we're trying to do. And in this case, we truly are trying to really lock in and bring new sources of revenue to help drive our leakage reduction programs globally. And if we can bring revenue to those problems, then that may get those problems solved. And so this is really the heart of it. So again, that tie between carbon and leakage. So I do feel a huge sense of gratitude and responsibility of being able to present this, but also feel like I did in San Sebastian, I just was one person moving it forward. Most of you on this call, and I've just mentioned a few that had a more active role in the development of the Leakage Emissions Initiative. Most of you have played a key part. But these folks in particular, first, the International Water Association Water Law Specialist Group, to me, establishing this, setting this forward, and then when I talk about the peer-reviewed publication and what that means, this group stepped forward with leadership, and I think that is incredible. And certainly globally, what we've seen with the water balance, with the periodicals, the manuals, the communications that have been going on, the conferences, the Water Law Specialist Group it continues to lead in this frontier. And so a nod to Stuart Hamilton and Bombos and others that are on this call for the work that we continue to do as the IWA. I also want to make sure that I comment on in North America, and I should have said good early morning from our California friends that I know are on the line, all the way to good late evening for the folks that are up late globally. But for the North American market, certainly the AWWA, American Waterworks Association, the Water Loss Control Committee has been extremely instrumental in this as well. Joining to, similar to what we did with water balance through our committee report, and fully adopting and pulling forward this methodology that I'll be speaking on today. And then just to see the names there of folks that have been extremely involved in either authorship, methodology review, communication, and many of you as well that are on the call today, but these especially sort of stood out as those that have been putting forward some effort and comments. I like to go to the landscape of this and really talk about it in terms of some numbers that you may not realize or you hear, but that really help us get our brain wrapped around it. And that is about 126 billion cubic meters of water is lost every year. That's a big deal. So we've got new supply that we can go get if we are reducing leakage. And so this is the catalyst for that piece. That's money. That's money that's lost of revenue that we could bill. And then to bring in play and start to get us moving towards the carbon piece, 11.9 billion kilograms of CO2. So the greenhouse gas that is emitted as it relates to the lost water, that is a huge number. And if we can start to tackle it and start to take credit for what we are doing, I think that that's going to continue to generate interest and also funding and momentum that helps water utilities move this to the top of the stack of their very diverse priorities that they have of what they're trying to do. So I like this also. That first slide was from Standard & Poor's. Second one as well is that Standard & Poor's now, and we've seen this shift really over the last 10 to 15 years, they're starting to look at bond ratings and communication of how effective and efficient a water utility runs its distribution system. And just a couple of comments here of looking at the investment and the deterring investment, but also they're starting to now list the mitigation of greenhouse gas. And to me, that's a step change and something that I think is something we should pay attention to. And that is really starting to look at it from that global perspective. And now institutional funding is paying attention. So to give a little of the history of this, and hopefully in some of the Q&A, my friends and colleagues can embellish us a bit, but literally 2 years ago, a little over 2 years ago, following the Water Loss Conference in Prague, there was a conversation. It may have been in a bar, it may have been in the lobby afterwards, that was talking about the tremendous amount of, well, first it was sort of wringing hands to say, we continue to look for funding and ways that we can push projects forward, reducing non-revenue water. And then it was almost a stark realization concurrently, there is a lot of money that is being put towards the reduction of greenhouse gas, carbon initiatives. And is there a way that we can definitively tie, and intuitively we knew that there was, but is there a way that we can tie distribution system leakage to reduction of CO2? And obviously, the groundbreaking work, late 90s, early 2000s, on the water balance and getting that to industry standard. And like all of you that are on the call, and I'm going to spend some time talking about the water balance and how that relates to the carbon balance, but we still have work to do on education there. But can we now put another tool in place that is easy to grab hold of by creating the carbon water balance? And can we do that in a way that would make sense? And then get that word out, which is part of this effort. So that really put in play the impetus for the Leakage Emissions Initiative, and how we put that together. And obviously you've got quite a bit of a global push out there from looking at the Paris Accords and what countries are trying to do, but finding a way that we could assemble the global water leaders that could look at it and have a definitive way that we could put a methodology forward. So I actually want to go to the website. We created a initiative website, even though this initial initiative is winding down, and we're working on kind of a final summary report. This will be part of that as well. That Leakage Emissions Initiative website will stay active. And I'm going to show a little bit of it because I want you to be able to look on your own, have a chance to look around, because there's 2 years worth of data, information, resources, participants that are on there. And then what we hope, and I'm going to spend time at the end of the presentation talking about case studies, as we continue to get the word out, educate on this initiative and the direct tie, we want to have case studies that we're having utility after utility after utility start to tell their story of how they are reducing greenhouse gas through their leakage reduction projects. So very quickly on this, you'll see, and I'll talk more about this, but now there's over 93 professionals that are involved from now I think it's 35 countries that are involved in this. Take a look at some of the folks that have been a part of that. The resources that are out here are incredible. I'll come back to the white paper, but that is the first item that's listed. There's some presentations, there's calculators, there's discussion of scope 1, scope 2 emissions. There's a number of research papers. So I encourage you to look at some of the resources that are on here quite a bit. And then if you want to just sort of see the formation, how did this get to be, the actual meetings themselves? Take a look. Some of these are recorded and some of these are minutes. And then I'll spend some time, as I said, later talking through some case studies. So I wanted to make sure that was, that you knew where that was. Let's go back to here and here. So I want to talk about the white paper now. So the history of this is this group, we developed a concept, what it is we were trying to do, what the folks that we wanted to assemble. And it started with really 22 nations and 50 or so water professionals that started discussing, looking at what resources were out there. We had conversation about, well, how does a utility that may be in the Caribbean that has a certain energy need based on desal, how does that compare? How do we, look at ways to look at the energy consumption, where they get their energy from, and just walking through several different scenarios. We had a lot of discussion about, should this be something that we spend time on the conservation side of it, on the demand, on the actual customers, and hey, there's more to be gained on that. And that's a very valid point. But what we did through this process is really bringing it down and saying, we're going to focus on leakage. And let's do this in a way that, again, it's defensible and it's something that folks can grab hold of. So this group worked together, as I showed on those meetings, many meetings, getting to that draft. This draft is now published. It's the first link that you'll see there through AWWA. It's peer reviewed and it is now being referenced. I'm excited because I see this probably every couple of weeks. There'll be something that references this, and certainly the case studies are now utilizing this. But to actually give the methodology and detail of how we got here. In 30 or so years, this is probably the fastest that I've ever seen something come together like this, so where there was unanimous agreement on the methodology and the way that this should be pushed out. So let me explain it very quickly. And it is simple, and I think that's what's leading to the stickiness of this. And I would say that as we continue to have the desire or the drive to, hey, let's go a little bit further, or what about, this repair methodology, or what about changes of this component or that, I encourage us to not kind of outsmart ourselves. Let's keep it as simple as we can, because as we do that, that's going to continue this momentum of awareness. And how it works is this. You need to know how dirty the energy is that's coming into a water utility. So this is in terms of grams of CO2 per kilowatt hour. So every utility, energy utility, is creating electrons that we are utilizing in our distribution systems. And what is the fuel source? Is that coal? Is that natural gas? Now starting to look at some of the renewables, solar, wind, hydro. But wherever that source of energy is, we need to know how many grams of CO2 we actually have. Secondarily, how much energy on an annual basis does the utility use to deliver its total annual water production? So that's getting us to the kilowatt hours per cubic meter or million gallons. So again, two numbers that we can get our hands around on the water utility side. I'll come to how dirty is the energy source in just a minute. Well, what that gives us is a utility-specific carbon intensity, and that's in grams of CO2 per cubic meter. So I want to go back to this annual water production. This ties in nicely with the annual water audit, if you will, and globally we're now getting to where water utilities are seeing the value of not just taking how much did we supply minus how much did we bill, taking that difference, dividing back through by our system input volume for this percent unaccounted for water or percent water loss, incorrect term, but out there in the industry. Well, this annual basis or this annual snapshot allows us to now say, okay, on an annual basis, we're looking at the energy that we used, and that gets us to a utility-specific carbon intensity for the entire year. And that's how we can apply this to the water balance. So again, it's very straightforward, it's very simple, but it also makes sense. And again, I believe that that's why this has gained so much traction and is gaining traction, and it's because of the stickiness of this. So very quickly on where do we get some of the components here. So the first one is a number of resources that are out there. This is one resource. It is in the white paper, electricitymaps.com. So this is a resource that you can see I've got it highlighted on Poland here. You can mouse over, and the utilities are feeding in this information, and this think tank and free source that's out there is actually updating in real time the carbon intensity associated with that energy. In this case, in Poland, 730 grams, the way you read this, per kilowatt hour that is actually being produced. So this now gives for a utility in Poland that may be coming off of this energy source, and there are lots of nuances. Well, how much do they cogenerate and so forth that could be going on from, within their utility themselves, if they're capturing digester gas and cleaning that and so forth, or using that for energy. But again, I want to make sure that we're not trying to make it so complex that we dilute what it is that we're trying to do, and that is give it a defensible measure of the carbon associated with our distribution systems and thus the leakage. But this is one resource. eGrid is another resource that's out there, and I'm sure there are even more that I'm not aware of. Some of you probably will be. So I want to go to the water balance, and you'll see that in the green boxes here, we now have applied that math, that utility-specific carbon intensity for each volume within the water balance. I have to, because we need to do it every time, and that is to spend a moment to talk about the water balance, which has been foundational for this, of looking at it and helping us to really start look at it in a component type review, if you will, of a water utility that gets their water from their own sources. That's our volume from own sources. Some water utilities may import water. Well, that gets us in aggregate the total system input volume. Very important, I would say. And please continue as water professionals out there to volumetrically test those source meters to get better metering, better understanding, so that our starting number as we're looking at this top-down water balance is as accurate as it can be. We may have some water that's exported. This, incidentally, is from the AWWA free water audit software, but it's the exact same as the IWA codified water balance. But if you're taking off the water exported in our distribution system, we're now really starting to focus in on that water supplied in our distribution. From water supplied, it is a balance. We're taking now our authorized consumption, and that's both billed authorized consumption and unbilled authorized consumption. Our billed authorized consumption is what we routinely know that, as I mentioned earlier, is our meters, our billed customers that are out there, our largest component from our authorized consumption. And then starting to now look a little closely at our unbilled authorized. This is system use. This is flushing in that unbilled, unmetered consumption that's out there. Very important. And if this is the first time you're seeing it or thinking about it, is that there is another very necessary use that is not leakage, because it's authorized use that's out there, but it's trying to improve the way that we're accounting for that. That's not where we stop, because that, if you take water supplied minus authorized consumption, it does give us water loss, but that's not just leakage. There also are apparent losses in our distribution system. And the apparent losses is water that gets to a customer, but it's not properly measured or billed. And it is what we could sell that water for. So it has a commercial impact. It's also sometimes called commercial losses or paper losses. The largest components typically in this area are customer metering inaccuracies or slippage in our meters that are out there measuring the customer consumption. So again, just taking just a moment to talk through those other elements of apparent loss, systematic data handling errors, and theft. And theft is a big deal in some areas of the world, more so than others. I truly encourage that if you haven't done it in your water utilities, and those that are on the call that have seen this 1,000 times, please continue to tell this story. Tell the story that we must break down our use and our loss by components to be able to then come in and attack it. For the purpose of our Leakage Emissions Initiative, we're going to focus on the resultant, the top-down real loss that's here. And so now applying those utility specific carbon intensity, as in the grams of CO2 per cubic meter or per million gallons, that's just math all through the water balance, which gets us to the carbon water balance that's here. So I want to go deeper. I want to now say, okay, how do we really capture the total carbon associated with leakage? And we have to have a leakage reduction effort out there. So just following along, and I'm going to simplify on purpose a few of these things, but it really will grasp the main concepts. Taking from our top-down water balance, we've got our water balance real loss, that's in total. But we also know that in our distribution systems, over the course of a year, there are leaks that we have interacted with. We have gone to, we've repaired those leaks, we've made an accounting of those leaks. So of our water balance real loss, a portion of that is reported leakage that we know about. There's also a portion of that leakage that is background leakage. that is system specific. It's how many miles of main we have, how much pressure we're operating under, number of connections, infrastructure condition, those elements that gets to this background leakage that in a leak discovery project, we're probably not going to get that. We're not going to get that through traditional acoustical leak detection and recovery methodology. Pressure management, asset rehabilitation, certainly. But for the purpose of really tying it to something that hopefully everyone on the call thinking about how in our distribution systems, if we now deploy resources of doing leak detection for that hidden leakage, we're going to focus on that unreported. And that's this area here, which is, we'll call it recoverable. Now we know that it's not all recoverable, but again, to help grasp a project here. So now if we look at it, in this case, we put the carbon component to it. You just, again, it's simple math that I've shared. But if you look at that, that's 3,700 metric tons if we're able to get at and get to this recoverable leakage. So that's something that's not nothing. It's something substantial. And so I would think about that of, okay, now we know about this. We've gone through, we've done our water balance, we've done our component analysis that's given us an estimate of what our unreported leakage that we might put forward and start to try to discover and repair. And it also has a carbon component of 3,700 metric tons. So again, something to think about. This is the calculator. I'm showing this from the AWWA committee report. There's a calculator on the website if you go through the resources piece. And again, just by showing by example of how to look at this, in this case, 37,000 megaliters per year, pulling off of an electricitymaps.com or eGrid of how many grams of CO2 per kilowatt hour for that utility's energy source. How many kilowatt hours that they use, that could be from their utility bills. Could be that it's a total and they're then figuring out, on a monthly basis to get to what their rate is to get back into the kilowatt hours that have been used per year. But that gets to the utility specific carbon intensity of 328,000 grams per megaliter, or in this case, 1,242 grams per million gallons. Now we take that same leak reduction project and say, okay, what is our target leakage reduction for, or in the case of case studies, and when I get to case studies, this will make more sense. Many of us on the call have already done leakage recovery projects. We've gone out, we've made the repairs, and we should be able to calculate and show the carbon that's already been reduced. So let's use that sense and say this project reduced 5,400 megaliters per year. Work through the math, get to the number of metric tons. That's 1,800 metric tons of carbon that's been reduced. So again, the concept in this webcast is to get us to think about that of not just a leakage reduction project, but also a carbon reduction project. And the more we can tell that story and show it defensively of how we calculate it, I think we're really going to continue to make a dent in certainly the leakage. It's going to help propel and bring sort of that NR, that new revenue, to the non-revenue work that we do. When we started the initiative, we spent a lot of time thinking about the carbon, the credits, we'll call it the credits, and I'll come back and describe the carbon leakage credits. This primarily came from an understanding of how folks are trying to get to carbon neutrality. When I say folks, I'm talking about multinational companies, BP, Shell, Nestle, others that they're doing activities that have a carbon intensity of, let's just say 250 as an example, use a number. Well, if they can invest in carbon activity or in activities that are reducing carbon, say leakage reduction project, which now has been definitively tied to carbon reduction, then that might have a minus 50. Well, that helps them get closer and closer to carbon neutrality. And there's a lot of that's been going on globally of how companies that have to make products that are carbon intense and their activities, then they are offsetting. And so we thought about, and we're still discussing the carbon leakage credit perspective. And that's where I think we still have work to do. To do that, there are registries Gold Standard, Vera, CAR, several out there where the methodology can be registered. And then once it's registered, then those credits could be posted and could be purchased to where that could bring that revenue source in. A couple things we learned about a year ago as we were submitting to one of the registries was there was a little bit of pushback because there were no real new registrations that were being done because quite honestly, the registries had gotten a very poor name for greenwashing. That everything all of a sudden was a carbon credit or was and there was a lot of concern about that and so they pretty much squashed that down and said, we're going to hold off on any new registrations. We think that there now is potentially an opportunity. We have another application and a concept note that is under review. So I'm excited about that and to see where that goes. Also would say that we need to have caution because as an example, if the carbon leakage credit is valued at $5 a metric ton versus its value, which could be 100, some number much larger, it could be that it really is not a needle mover. And one of the closing slides I'll talk about is how long should we even count that? In some cases in the agricultural sector, certainly in North America, they're allowed to calculate that for 10 to 15 years of avoided, in this case, emissions credits. So this is something to think about, but we're not done. We are continuing, and this is something that we think may continue to be an area in the carbon leakage credit where there can be some funding that comes as a result of that. What I do want to talk about, and I'm excited about that is happening, and we're seeing more and more robust conversations about this, is in meeting the NDCs, the nationally determined contributions. And this is an area, certainly we've seen it in the states, where there are goals for every country of meeting certain standards, carbon emission standards by a certain year. And if we can now start to have the conversation, the dialogue and say, if you fund a leakage reduction project, you're now as a country helping to get to your NDC, some of your targets that are out there. By example, and think about it on a country standpoint, this is the state of New York with a statutory target that's out there. Just to read them to put some example to this and think about it on a country level, trying to get emissions 40% below their 1990 levels by 2030 and not less than 85% below 90 levels by 2050. So the conversations that we're having it is with the sustainability managers, the folks that are responsible as a state for meeting these objectives. And the conversation is going like this, how are you meeting it? And there are things that they are doing, but it's also introducing the concept of, hey, can we move forward funding to municipalities within the state of New York that can actually now reduce their leakage now that we've got this AWWA defensible methodology of calculating the carbon associated with that can help them get to, as a state, their goals. So that's something that we're at least seeing more conversations, more interest in that. So that's helping the state get to some of their zero emission goals long term. The insetting piece, I would say, is something that we need to spend a moment talking about. And this is helping companies, or I've talked a little bit about the individual states, but I will go back to one of the calls that we had on the initiative, and we actually brought in representatives from BP. And there was quite an interest of looking at it. And we actually were introduced to the term charismatic projection. And the interesting thing about the water industry and the reduction of leakage, while it simultaneously is reducing greenhouse gas, is in many cases, we're now able to pair those together. And certainly for multinational companies that have environmental stewardship, greenhouse gas initiatives in their shareholder discussions, their goals and objectives, their strategic plans, there is a tying together of these two initiatives, which is very, very interesting and certainly is growing a lot of attention. The last one I'll say is a lot of these areas also where these companies are located, they're also in areas that may be impoverished or may have challenges with rates, disadvantaged communities. And so that's really a triple effect, if you will, of if we're able to drive and now we've reduced leakage. So now the cost of water can potentially go down. And oh, by the way, we reduced this many metric tons of carbon. So I think that this is going to be a continued evolution and story, but it's going to take everybody that's on this call and the folks that see this webcast to tell it and to communicate of what it can be. So there are some things as I get close to a wrap here and get to the case studies that I would say are horizontal. So, you know, we continue our looking for a verification step. We're working on that. We need to fill and continue to communicate, and hopefully many of you will share your story, your case study out there of what you've done. Education, obviously, is a continuation of things that we've started, but even though this first initiative is coming to a close, we've got to have the 90 plus that are a part of this to continue to get the word out. I have seen things that that have come back, and that would be this. I'll go to the bottom one first because this really frustrates, but I think we have a good answer for it. And that is, hey, why should we be giving credit for something that the utilities should already be doing? And the answer that I give on this is, but the leakage project has not gotten to the top. There are many other things that have got to be done, that need to be done in a water utility, but leakage has not really made it to the top. But if we can bring additional money that triggers this, that gets it to push it over, then we really are on our way. And so that would be why wouldn't we do it and pushing it there? And then things to think about, the time horizon that I mentioned, you know, because if you don't interact with that leakage, it's going to continue to leak. And so they're going to continue. We've got our runtime that's going on, but we're also going to probably be increasing in that leak because we haven't addressed it. So the leaks don't get better over time, they get worse. And then certainly, as we see in the industry as water professionals, what about that new leakage that occurs after a project? How do we account for that and look at it? Well, that's where if we do a carbon balance each year and we're looking at it, I think we can address that. So very quickly on the case studies, I want to bring up a couple real quick to show, and then we'll get to some Q&A on this. So in looking at it, as I mentioned, there's a template where we actually talk about what makes a good case study. I would say, quite honestly, this is just some guidance to work from. Please bring them forward. Just some things to think about. It goes through the methodology in the background as folks get their hands around it. So the first one I want to do is the very first one that was put together, and excited. Stuart and Avalia from Mia Water looked at Jamaica and said, hey, we think we can pull together information from a pretty robust leak reduction project that was done from 2016 to 2022. And again, applying the methodology, the carbon intensity associated, there was the direct physical loss from the system, there was the recovery, and then getting to that on an annual basis of looking at what is our cumulative carbon that has been reduced over the life of a project. This is to help you see for a longer term project that there is real carbon and hopefully real money that could be associated with that carbon of moving forward. So there was Kingston and then also Portmore. Again, these were the first two case studies that were produced. I then want to go to one that Marco Fantozzi brought forward, and that is in Italy. So this is a case study from Reggio Emilia province in Italy for Dewi and Marco, if you're on the line. Sorry about butchering that. But you can see here, again, what was the leakage volume that was reduced per year, again, using the water balance methodology, and then also an estimation of the leakage that was removed. That then was calculated in the total metric tons of carbon that were reduced to get to a total over the life of the project, 411 metric tons. So as you can see here, carbon intensity, I would say fairly low in comparison to maybe Jamaica or another Caribbean island. Again, to help latch onto this, if you're Vienna, Austria, and high mountains, gravity-fed water, a little bit of treatment, and by the way, maybe it's hydropower or wind or solar, a lot of green resources, the carbon intensity of that energy and the energy that's needed because it's a gravity system, quite a bit less compared to if you're having to tanker in diesel fuel and then run a microturbine to make the electrons. And by the way, you have a desal plant. That's quite a bit of both carbon associated with the electricity, but also energy that it takes. So it's going to be all over the board. The purpose of the case studies and really getting the word out, and hopefully these will be lots of presentations in Rio and other places where we have opportunities to share, is to bring them forward. We'll say it doesn't matter where you are. It's important that you are starting to look at it, get a good look and pay attention and post out there. The last one I'll show is a recent one from, let's go here. Maybe. Yeah, let's go here. All right, Mulaney, let me ask if you are seeing a Word document on the screen. Can you come back to me and let me know?
Yes.
Okay, perfect. All right, this is Portland, Oregon, and super excited about this. So Michael Thomas, who is one of our Leakage Emissions Initiative members, has been very active, has just put forward Portland. It's still under review, but what I'm excited about is several things. One, they are really leaning into key performance indicators that are different than percent water loss, and looking at it in terms of gallons per service connection per day, which is exciting. Also, infrastructure leakage index. So, but the thing I'll also share is they have a very strong, that you can see that they've used electricitymaps.com to pull their carbon intensity. They have a very low carbon intensity of their power, so 233 grams of CO2 per kilowatt hour. And still, for them, it was important because of looking at it and recognizing that as we do a leakage reduction project, and in this case, they reduced 365 million gallons, again, based on the water balance, year over year, looking at it, applying the calculator, that still meant for them 62 metric tons of carbon. And I'm excited about this one because that shows kind of in a very low carbon intense environment of where it still makes sense to do it and to get the word out. So again, just a couple of case studies, and we need more case studies to come forward. I'm excited that we're starting to see folks really lean in and look at it. So let me end there, I think. Yep. So I'll do this as a landing if anybody needs my contact information. And then I'm going to actually stop there. And Mulaney, let's go ahead and open for questions. And hopefully we've got controversy and new ideas and things that'll help us advance here.
That's perfect. Thank you, Steve. Excellent presentation. We do have a few questions, but I'd like to remember everybody about the next webinar that will be introducing the Carbon Initiative on February the 12th. In the end of this webinar, I'll put in the screen so everybody can see, and it will be, we can look out for this, the register in the next fortnight newsletter. So anyone that hasn't subscribed it yet, please feel free to join us. We do have a few questions, Steve. Gary Trotman asked before, does the calculator consider any carbon generation associated with leakage reduction activities such that this calculator is a net carbon reduction?
It's a great question, Gary, and thank you for being on and have been a part of this as well. So if I understand the question, you would be thinking about other like some of the pressure reduction, some of the in-pipe energy and things like that. Is that what you're talking about, of a net of where we're able to benefit from that? Is that the question? Maybe let me get a clarification.
Well, the
You
first thing
can
that comes to mind, is truck rolls associated with
Yep.
leak detection activities.
Yep. So you're talking about the actual repair of, hey, you're putting new carbon in to go and make that repair. So we did have a great conversation about this that actually led to an education of scope 1, scope 2, and scope 3 activities. So in this case, the utility, they would be looking at it and saying, okay, can we, as efficiently as we can we look for vendors that are going to actually be doing lower carbon activities for repairs? But that's really a part of that company's activities that they would be doing. They're the way that they do business. So that's really a part of their scope 1 or scope 2 activities. So we decided not to delve into the repair piece of this, Gary, and say, okay, well, but we reduced 62 metric tons of carbon, but it cost us 10 metric tons, so it's a net. I don't know that that's correct. But again, that's a great topic for our next initiative of looking at it, because from what I understand about the next steps, it's to help utilities start to get some sort of ranking of where their carbon, where they are as a carbon utility. But again, that's still yet to be determined. That's why we chose not to do it, Gary.
The next, is that okay, Gary? Can I go on for the next one?
Well, I was just seeing that, including that as another way to encourage utilities to look for the least carbon intensive approaches to finding the leakage, not just the repair. But yes,
Fair
thanks.
comment. Mm-hmm.
Okay, next one.
Can I just jump in, Melanie? The
Sure,
next
Mark.
webinar that Melanie just mentioned and the next initiative, the carbon initiative, is pretty much exactly looking at that, Gary. So as Steve just mentioned, we're starting a new initiative. And I think if you join that webinar, you'll see that a lot of what you're asking is going to get addressed in that upcoming
Very
initiative.
good. Thank you, Mark. Thank you, Mark.
Okay, next question, please, asking, will the methodology work for developing country water networks?
I would, and we get this question a lot. You know, it's too early for me to do the water balance. You know, I don't have meters. There's a lot of this that happens globally. The answer is yes. The answer is yes. You can and should, even if it's estimates. The reliability of the information, it may be not as reliable, but you can get more reliable over time. We always say start. If you don't have meters, as an example, you can make an estimate of the number of people in a particular residence, as an example, to get to a proxy for the volume. So the answer is start. That gets you to allows you to do the water balance. That gets you to do a tabulation of the total water that is produced. And then certainly you're having to get that energy from somewhere. So it's whatever tabulation of where you can get that energy of how many kilowatt hours it took to pump and treat that water. And then from a public resource like electricity maps, that's global. You can at least get an estimate. So the answer to that is yes.
I'm gonna hurry a little bit, Steve, here, because we have
Sure.
we are getting a lot of questions and we have like 10 more minutes, 8 more minutes. Andrew Strasner is asking, given how carbon intensive PFAS treatment is, whether GAC, IX, or
Yes.
RO, is accounting for that emission source included in the calcs yet? We've been trying to raise awareness on revenue water with these systems, as the variable production cost is often approximately 2 times when accounting for consumable GAC and IX for PFAS treatment.
Yes, fantastic question. And this actually is a very big deal. And it's going to help us. It's going to help drive leakage reduction projects because in earnest, the cost is going up. It could be 3 times as we're now having to handle PFAS. So that's going to make our economic driver much, much higher. It certainly also is going to increase the amount of electricity that's being used. So great question, and I appreciate you putting a circle around it. The cost of variable production cost of water is going up, and that's going to help drive this.
Okay, next one. Kate Stanton Davis is asking, can Steve remind us when the AWWA the WAS, including the carbon calculation, will be publicly available?
Yes, we were on the Water Loss Control Committee yesterday, and I heard a commitment that it is by ACE of this year. The Free Water Audit Software Committee is already working on establishing the working groups to get to this, but this is a big, big push for them. So June or so of 2025 of this year.
Okay, we have a comment from Tom Kennedy to Peace, considering that last year, Steve and I worked on a project on Sri Lanka to develop a LEI calculation for Colombo, but the available electrical consumption data was incomplete. This makes the calculation practical. If you have good energy consumption data and get GHG contributions from electricitymaps.com, you can do it anywhere. So just a comment so anyone can hear. Amit Sharma is asking, any good questions to ask utilities to get this data? If you have good energy consumption data and get GHG contributions from electricitymaps.com, can we create a global data entry for this and pull info as needed? Is LCA life cycle assessment of carbon needs to be focused?
I mean, I think this is an excellent topic and something that the water community needs to think about of how can we continue to expand this. So I think that may be a really good idea, really good comment for next steps for sure.
Okay. Yeah, that's the end. And Andrew is saying, thanks, Steve, great presentation. And I'm trying to put in the screen for the next webinar. It's here. So everybody can remember. Steve, any last thoughts?
Yeah, I just really encourage, as I mentioned, this initial initiative is coming to a close, but there's a tremendous amount of momentum, and I'm concerned that we need to have some way to continue to communicate about this, and I think that comes through case studies. I think that comes through this next initiative. And I really encourage folks to join and be a part of that and continue to push it and advance things forward. But we really also need to fully engage the international funding community. Every opportunity that you get to be able to talk, whether it's GIZ, World Bank, USAID, the country sustainability managers that are trying to meet goals and objectives of some of these NDCs, have this conversation. Show these case studies and have a dialogue. If there's an ability to have an educational webcast or something that in 15, 20 minutes, you can get the grasp of it. Again, back to the stickiness of this initiative. So I just encourage us to make sure that we are doing our part to really promote and push this out there. That would be the only thing that I would offer. And then just the final is an appreciation for everybody that's on this call and that has been a part of this initiative. So that's what I would say, Melanie.
Yeah, just as a reminder, this presentation will be uploaded to the YouTube channel with all the other webinars. So probably within a few days, everybody can watch over there. If anyone wants to share it, feel free. And I think that is it. Thank you, Steve, for an excellent presentation. It was really great to hear you. I'm just stopping recording right now.
Thank you, Melanie. Thank you all.